Alright, what's up, everyone? Oh man, where is everyone? Missing like a couple people, alright? I'm gonna make the font extra small today. No, I wouldn't do that. Yes. Woo! Do you know, I mean, why would I even be able to make the font this small? Yeah, just a tiny little mouse, or a collection of mice, just all. Yeah. All right, what's up? Hey. How are things? Yeah, yet another day. It's I mean, what day is it even? It's week 2, day 3. That is whack. That is a whole day. It's just a whole new day. We're gonna save this file as file.md. I don't know. We need a name for it. We're gonna cover some pretty interesting stuff today. I really like this lecture. There's going to be some highly theoretical stuff. There's going to be some applied stuff. There'll be some drama. There might be some comedy. There might be some romance. There might be some intrigue. There's probably none of that. It's really just it's really just another lecture. Now, just to check in, how are you liking JavaScript? A good time? Nice. All right. Who feels that for the first time in your life you can communicate clearly? Right. That sort of half sounds like a joke, maybe, but I found, not with JavaScript personally, but there's been other programming languages where when it like clicks, just like, oh, like I can explain myself now. Right? I can give instructions, and the person to whom I'm giving instructions, if I write my code properly, will always understand. And that's great. I can communicate. Right? Not that I have some trouble communicating day to day, but programming at least makes it a little easier. Now, we're going to be talking about communication today. Specifically, we're going to be talking about networking. Right? Networking is a big topic. Networking. Here are Nima's hot networking tips. Right? If you want to network, I mean, you're talking to the right dude here. Tip number 1: firm handshake. That's really where it starts. Right off the bat, firm handshake. You got the job. Right? That's it. You've made that connection. The other person's like, yeah, I like the cut of this person's jib. That's a good jib, and I like the cut of it. So you start off with a firm handshake. Number 2, eye contact. Right? Make direct eye contact while you're talking. Kind of maintain that connection. That's pretty good. Let's see. Number 3, ask about their political leanings and religious beliefs. Totally great networking tips, right? You go in, handshake, eye contact. So how do you feel about Silvio Berlusconi, right? Like just right off the bat, and all of us kind of go, should you though? Should you though? Maybe not. If you're going in for a job interview, here's a big tip. Here's a couple $100 tip I'll give you right now. Don't ask about religion. Networking in real life is very much the same as networking between machines. Right? So in the same way that we look at this third tip and you go like, that's not right, right? There are some things we'll look at when computers are communicating with each other and we'll go, that doesn't facilitate communication. That doesn't facilitate networking. Can we think of like other things that you shouldn't do when you're talking to someone for the first time? Right? So, don't speak, really close to their face. Right? So I might say, here's part of the protocol, right? Don't speak really close to their face. Just don't do that. What we're coming up with here is a protocol. Right? To frame today's lecture is about networking between machines, right? Communication between machines. For no real reason, as in like these machines, they're just going to be talking with no real reason to them. And as you progress through boot camp, we'll find different reasons for why machines might want to talk to each other. I'm going to take likely the first half of lecture to kind of explore a thought experiment and to collaboratively come up with what we're going to call a protocol for communication. So generally, when we talk about communication, and there's a couple kind of questions that pop up. I'm just going to lay out some questions with no real answers to them. Question one, where are you communicating? Right? Where? That might make a difference. Like, geographically, or are you at a party? Are you at a bus stop asking someone, do you have a moment to talk about JavaScript? I don't know, like just normal human conversations. Where are you communicating might make a difference. Number two, who are you communicating to? Communicating to. That might also make a difference. Did anyone just come up with like things to think about when we're talking about like day-to-day human communication? Right? Or things that become part of that equation of how you communicate to someone. Is that a question or is that an answer to this? Yeah. Sure. I guess so. Yeah. Like how do you establish a connection? Sure. Right. In your case, it's a greeting. Right. Hello. Right. That's a greeting. Right. I'm trying to keep these very vague. There's no real right or wrong answer to this. Here's another one. Like, what's the medium? Right. Am I writing to the person that I'm communicating to? Am I just kind of shouting at them? Right? Am I showing them like flags? Right? There's many different ways of communicating, and each of these is going to have its own baggage to it. Right? So we'll explore this a little bit, the medium of communication. And maybe the last question that I'll put down here, just off the top of my head, but we may come up with more, is just straight up, why are you communicating? Right? Like, what's the purpose? You could technically, if someone starts talking to you, just small talking, you could do like a robot, like, why are you talking to me? Just state your purpose, so then you're able to decide whether you want to continue with that line of communication or not. But that's something that we think about. When you're talking to someone, you're like, what are their ulterior motives, right? Or maybe you're talking to someone and you've got, some reason for why you're talking to them. Right? Oh, I'll even put down another one. How many people are we talking to? Right? Again, I'm not talking about computers here. I'm not talking about you, necessarily talking to someone via a machine, right? I'm just talking about like if we have two agents in the world, right? Tim and Sally, and they need to get some information to each other, right? What are the different ways that can happen, and that. And the reason I do this is because you're going to find that as you go forward in web development, you're going to learn more and more that the stuff that you work with hasn't just fallen out of the sky, right? It's there for a reason. It's networking in TCP today, right? Okay. Oh man. I have so far never taught the wrong lecture right? In like 2 years, but you always think it's gonna happen. So we're gonna continue following up on this like thought process, right? And I want to come up with like a couple different modes of communication, right? And I want your input in on this, right? What are the different ways that people can talk to each other? And then we'll analyze each one. Right? I'll start a tin can telephone. Right? Tin can telephone, absolutely a way that two people can talk to each other. Right? Is anyone here not familiar with what a tin can phone is? Cool. All right. How else can people talk to each other? Yeah, sure. Face to face. Just face to face. All right. What's that? Letters, right? Letters, i.e. snail mail, right? Yeah. So I might write a letter, send it, and then I wait. All right. What else? Right, electronic media. I'm going to need you to be more specific than that, though. Email. Cool. Right. And the reason I'd say to like be a little bit more specific because there's so many different ways to do electronic media, right? So email is one of them. Snapchat, yet another one, right? Posting videos on YouTube, right? That's another way of communicating with someone. Have any of you seen the Vlog Brothers before? Right? So the Vlog Brothers, the whole like experiment of it was that they would greet each other via like a vlog every week or something, right? Right. So that's one way of communicating. Come up with more. Skype, sure. Right, Skype. That's like an evolution of that online stuff with the face-to-face kind of stuff, right? Slack. I love Slack. Yeah, so there's Slack. What else? Smoke signals. Yeah, all right. Just basics. Yeah, back to basics. Smoke signals. I love it. Morse code, right? So Morse code over like telegraph, right? Yeah. Let's come up with 3 more. Radio, sure. Right. I'm gonna just straight up say a phone call. That's one, right? What is a phone? And let's come up with one more. Yeah, texting. Cool. Texting, and then I'll put down walkie-talkies. Right. And I think one of the things that's like particularly interesting to me is you think of the simple act of like communicating just a message to someone else, right? Blow up a whole list with all this stuff, and they're all very different, right? And the longer you look at them, the more you see that they each have like nuances. Some of them are similar. It's like this big overlapping like Venn diagram of stuff, right? And we can start giving kind of traits to these. For example, I might pick, let's pick smoke signals versus versus Skype, right? How are these two similar and how are they different, if in any way at all? But, yeah, sure. Both convey info, right? So both convey info. Sure, and that's going to be like a general trait of communication protocols, hopefully, unless you have some communication, like if a new app comes out next year where you just literally send people just blaring sounds for no reason, if that's it, you're like, oh, there's literally no information in this. Great. If that was the case, I still think people would find some way of attaching information to things. But, well, when I say sound, I mean more like, and that's a great point. I meant like just static, right? You're like, oh, I just got a new static message, right? And that's your like final project. You're like, yeah, it's called static, statically, and it just allows you to send different like granular kind of lengths of static to each other at almost no cost. Right. So both convey info. Sure. What's the difference between these two?
One requires effort, and the other requires less effort.
Sure. So this one here is like less effort. I might even say like passive, I guess, right? And this one here requires some more effort, right? You gotta set up a fire.
Gather leaves.
What's that?
Gather the leaves.
You gotta gather leaves. You gotta like fan it. Yeah. Do you want to hang out today? Scene 3:54 p.m. or something. I don't know. Yeah. So sure, smoke signals require a bit more effort. What else?
Health hazard.
Sure, health hazards. All right. What else? Yeah. Yeah, the medium is air, and this one here you said the medium is? Yeah, yes, it's electronic. Let's say like it travels through, wire, and then the method that you receive it by is visual and like you hear it, right? So visual and auditory. Whereas this one here is just visual, right? That's a great point, right? The medium itself is different, and the way that we experience it is different. Then I'm going to put one more down. How quickly do I get a message with Skype, and how am I able to communicate? Instantly, right? So instant communication. Right? Honestly, almost as immediately as I can come up with a message that I want to send, I send it, right? And this one here, I've got to think about it, maybe figure out, right, what's the signal for it, and then do it. Right? And then the other person's got to pay attention. You probably can't have a very fast, like, you wouldn't see an episode of Seinfeld in, like, smoke signals, right? Like, that wouldn't, I actually want to see that, but what's the deal with maple leaves? I don't know. So smoke signals, we're going to say, like, slower communication. Okay. And really, that's something that we're going to find as we go through all of this stuff, is that they're going to have baggage that comes with them. Right? Snapchat, here's some baggage. It's what is it, 10 seconds max for like a snap. Right? Another bit of baggage can only happen via phone. Right? You can't send a snap like with a computer. Go like, why? Well, it's some arbitrary decision that the designers made. Right? So Snapchat can only happen via phone, and then let's say in the original model of Snapchat is messages are fleeting, right? You see them and they disappear, right? Kind of cool idea. Snapchat as well, right? This does not, in and of itself, right? If we were to say just a series of like videos that are sent to each other, snaps, does not have like a running thread of conversation. Right? There's never really any context to a snap. The context is like, who is this person and what do I know about this person? Right? So if we wanted to have like an in-depth conversation, with Snapchat it's going to take like an extra layer of organization, right? We're going to have to think a little bit more. We might have to agree ahead of time, right? Right? So it doesn't have a running thread of conversation, whereas some of the other ones, right, like a phone call does. Right? A phone call has a session. Right? You pick up the phone, you dial with someone, and then you're on the line with them, and you can just keep talking. Right? The phone, either one of us, of the agents, can talk at any time. Right? Either agent can talk at any time. So I would recommend that at some point you, like as a thought experiment, just take yourself through some mode of communication and think about, what are the things that are, positive about this? What is empowering about this thing? And what is a drawback, right? Or what is a bottleneck, right? The nice thing about smoke signals is, sure, there's health hazards. At the end of the day, you don't need electricity for it. That's kind of neat. You could set up smoke signals in the middle of the woods if you really need to like send out a message to someone. We're going to come back to this idea up here, but in slightly different ways. Does anyone have any comments about this stuff so far? Cool. So we're going to start designing our own sort of like messaging system, right? And the one that I'm going to pick is the tin can phone, right? The tin can phone protocol, right? AKA TCP/IP, right? Tin can phone protocol. This protocol is going to be made up of several bits to it. Right? We have to first of all describe what a tin can phone is. Right? So what I'm going to try and do with your help is we're going to write up a document where if we give this document to two people, with just that document, they should be able to set up like a working line of communication that they can have like rich conversations through. Right? That's the goal that we're trying to get through. And we're going to see that there's steps that we have to go through as we build it up. So the first part here is like, what the heck is a tin can phone? Right? What is a tin can phone? Does anyone want to describe what a tin can phone is? Yes. Cool. Right? Two cans with string attached between them. Right? So that's about it. If we go take a look at a picture, we might attach a. Why don't I have Chrome open? We might go and as we're drafting this document, find a nice picture. Like, ooh, this one here looks like something out of a patent, right? So here's the tin can phone. Actually, I might even just take that image and just put it in. There you go. I got my document with my tin can phone. So two cans with a string attached to them. That's really about it. Here's kind of a special thing to note. The string must be taut. Right? It must be taut. Because if you just got loose string, you're just shouting into a can, right? We're people of science here, right? We have to stretch the cans out so that the string is taut for the signal to go through. Right? That's about it. What we've done here is we've physically defined the system. Right? Physically, you need these things. Right? Do I have a document that fully explains how to use a tin can phone? No, it doesn't really say that yet. Right? Because now I get to dive into basic usage. Right? What do I need for a tin can phone system? Right? What are the basic needs other than physically having two tin cans and a wire, right? or a string? Right? What else do I need? Yeah, basic usage requires two human beings, right? And what should the human beings be doing? Right? Yeah, so requires two human beings. Tin can phone is for talking, right? As well as listening. Right? Tin can phone is for talking as well as listening. And we might even lay down a couple very basic instructions here. To talk, place mouth at edge of can. Maybe not right at the edge because they're very sharp, but just around there. Place mouth at edge of can and shout. Right? You'll probably want to yell into it. To listen, place ear at edge of can and concentrate, I guess. Just place ear and just listen. I might place it to hear. Place ear at edge of can and listen. Very, very basic usage. Is this enough to have, again, a working, like a rich conversation between two agents? Right, two people. Right? Maybe, maybe not. Right? How would you use this tin can phone? Right? If I wanted to have a conversation, like the two of us want to have a conversation, right? I am in possession of one of the cans, right? You're in possession of one of the other cans. We have now, we have the string attached to them. They're far apart from each other. I didn't even say this, but each human takes a can, right? So that you're standing far apart. And then we've already said that the string must be taught. And now what? If I want to tell you, you want to go for some pizza, right? I know that I can talk and place my mouth at the edge of the can and shout. And is it guaranteed that you'll hear me? No, right? And why is that? You wouldn't know when to put it at your ear, right? These instructions, they say that basically, like I can, if I wanted to transmit something, I can shout into it, and if I wanted to listen, then I can put it up to me. But we haven't said anything about, oh, well, when you start up, you should start up listening, right? Or we haven't said anything like, oh, if you're looking at each other like really far away, you should like wave before you start talking into it so that you make sure the other person's on the line, right? There isn't any of that. Right? So while this establishes, maybe we say like transmission of a message here, it doesn't establish the fact that, oh, like someone's gonna actually hear it, right? Or that you're gonna be able to have a conversation, right? We're getting a bit closer. We're getting a bit closer, but we're not fully there yet. Right? Do we see the drastic difference, though, between these two things? Right? One is a physical description of what you have. Right? This other one's getting a bit closer to how you use it. Right? A bit closer. So what I might want to do is put on like a little bit more of a set of rules here. And this set of rules is going to be a little bit richer in terms of it's not just for sending a message, but ensuring that a conversation happens. Right? So we could call this, you can come up with any kind of conversation flow, maybe. And I might like really spell this out. Like number one, the two agents, right? Two agents, A and B. I use the word agents to mean like humans or users. The two users, A and B, both enter the system, right? Meaning that they've fulfilled, these things up here, and they've both taken a can, and they both know that they can talk into the can and listen to the can. They're both aware of that. Right? The two agents both enter the system, right? And then I might say each agent immediately begins listening. Right? As soon as they've connected, now they've both immediately started listening. Now, I might want to say how to actually send a message. And we run into a little bit of a conundrum here. Because I could say when an agent wants to send a message, right, they perform talk. And then I might give these names talk and listen. Right? So when they want to send a message, they perform that talk action, which I've written up here. Okay. And here, I'm going to say listen. Right. When they enter, they both immediately listen perpetually, right, until they have to talk. Right? And by nature of the thing, you can't talk and listen at the same time. Right? That's something I might want to write down. Right? Note. It is physically impossible to talk and listen at the same time. There's no strict format to this thing that I'm trying to build right now, right? This document here, this isn't like a real document with a standard or whatever. This is just me trying to figure out how I'm going to put together my tin can phone, right? And then explain this to my friends so that we can have conversations, right? And I'm realizing that as I build this out, there's different layers to it, right? There's the physical layer, right? And the physical layer, like I might decide to change some parts of that, right? Oh, my friends say they don't like the the tin cans are too sharp. Fine, I'll put like a weird kind of covering or one of those fluffy toilet seats or whatever, like around it, so that it's like soft. Cool. That doesn't break the rest of my system, right? We're splitting this stuff into stuff that's sort of modular. Right. So when each agent wants to send a message, they perform talk. Now, what's my problem here? Right, two people are listening. I decide I want to send a message. I start talking. What might I run into? Yeah? Yeah, right. So they may talk at the same time. They perform talk. Oof. The other agent may talk at the same time. So I might want to come up with a better solution to this. Right? So this is going to be like not 3. It may have been what we wanted to do, but now we have to figure out a bit better solution around this. We can come up with all kinds of ways of like solving this. You know, I might even write this down in here and just like an option for sending a conversation. When an agent wants to send a message, they perform talk. Note: the other agent may talk at the same time, in which case your message, well, actually, in which case neither message will actually be received. Right. What are some ways of solving this? That's what we're doing right now. Yeah. What's that? You may want to send a signal when you want to talk. So option, maybe send a signal when you want to talk to let the other person know. Sure. So what would that signal maybe look like? All right. So waving, if we have like a visual kind of connection, what if we don't have a visual connection? Right? Like there's a can and then thing and it just goes forever. Or maybe there's trees or something and I can't see them. Right. Okay. So maybe Roger. Right? You were going to say something? Right? So Roger says send a signal when you want to talk. And as an addition to this, send a signal when you're done talking. Right? That's cool. Right? So then if I am listening and I hear that, oh, this person's about to talk, I might not say anything until I then hear them say that they're done. Right? Does this actually solve our problem, though? Why? Yeah, they might both just send the signal at the same time. Right? They might just both be like, I want to talk, and then they just start talking. Because if you send that signal, you can't hear. Right? So we might want to add a little bit of like extra stuff on here. Maybe we send the signal, and then we wait for acknowledgement. Hey, can I talk right now? And then you wait. And if you get back an OK, then you can go ahead. But if you say, hey, can I talk right now? And you go back to listening, and you don't hear anything, then the other person's either not on the line, or there's a chance that they sent a message at the same time as you, so both of you missed it, right? And then I might want to try that again. It's like, I don't know, whenever I talk with my grandpa, he just talks, like he just goes off. Well, we like talk every weekend, and he's like, hey Nima, how's it going? And then he just talks about sports and politics. He's in Italy, so he'll just go off about Formula One, soccer, got really into like motorcycle racing. He doesn't race, like he's like 92, but and I've got to do this, like grandpa, and then eventually, like, because we're both talking at the same time, he can't hear me, and I have to like catch him on a time when he's not talking so he can hear me. And so yeah, that might be something we have to do. Send a signal when you want to talk, and then we wait for acknowledgement, right? And I might write like a separate little thing that says, you know, when you receive a a request to talk, right, with whatever signal that is, send back an acknowledgement. Right, wait for this one here would be wait for acknowledgement. If received, talk. If not received, right, try again. And now this is getting closer to that guideline. I could print this out. I could put it on my treehouse just wall, and you know, whenever people come over to the treehouse, they're like, "Oh wow, you got a tin can phone!" I'm like, not only do you have a tin can phone, that tin can phone protocol, you can ensure that all your messages are sent and received properly. And they're like, "Why do you always do this? Why?" And so here we've started the beginnings of a tin can phone. There's more that we could do. There's more that we could do, and we're going to come back to it in a second. But I want us to kind of, again, take just a deep breath. Like, you smell that? What's it smell like? It smells like a fresh-baked protocol is what that smells like, right? Like this, very nice, right? It could still be a little bit more. I'm going to leave it in the oven for a little longer. Throw a little bit of stuff on here. But it's coming together. Right? We got a stew. We're going to look up the word RFC. Does anyone know what RFC stands for? It stands for literally like so many different things. It's very much a loaded question. RFC stands for request for comments. I'm sure it stands for other stuff too. Rockcliffe Flying Club, right? We're looking at request for comments. Right? And a request for comments is a specific kind of document. Oh man, this is teeny tiny. It's a specific kind of document from the technology community. Did you know you're part of the technology community now? Right? Wow. Congrats. Yeah. Specific document from the technology community. You know, it may come from many different bodies, such as the Internet Engineering Task Force. What? Internet Engineering Task Force? What is this, reboot? Like, yo, it's the Internet Engineering Task Force. Yeah. Great show, by the way. Right? Or it might be the Internet Research Task Force. Or the Internet Society. Right? Or it might be there's the W2D3, the World Wide Web Consortium. Right? There's all kinds of different organizations that may put together documents once in a while. What these documents usually are big documents that like a couple of people have collaborated on. They've come up with a new standard. Right? That standard may sometimes be a standard for communication. Right? It may be a standard for a new language. It may be a standard for just a new data type. Right? And they write it up. They send it out. And say, hey everyone, this is what we made. We'd like some comments. Does anyone have any comments that they want to make on this? Any changes that you would like? And you're free to send an email and be like, ugh, I don't like it, change this. And so these standards evolve over time. And what's really cool is these things are public. Here's the RFC for HTTP. We will talk about what HTTP is. Right now, I just want you to see the word protocol. Right? Very similar to our tin can phone protocol, except this one here is, I don't know if you can see the scroll bar moving very slowly. It's very long. It's got, oh geez. It's got 176 pages, or just about. Right? And what it is exactly what we've built, but in a lot more detail. Right? A tin can phone protocol 1.0. It includes, and then they might say like the physical stuff and yada, yada, yada. Right? HTTP here is going to be just one part of our like tin can phone protocol. Right? But that idea still exists of putting together a document. Right? And like I said, we're going to dive into HTTP later, so don't feel like I'm just like glossing over it because I don't want to talk about it. Right? Yeah, and then at the top here, all the people who put it together. Wow. Dr. Microsoft. Yeah, so we're going to dive a little bit further into our tin can phone. Right? Knowing that this is a thing that we can build. I'm going to ask myself some questions. We got this conversation flow. Right? Two agents both enter the system. Each agent listens immediately. Right? I might want to do something like let's see, let me say handling sessions, right? And the questions that I might ask and answer in this section here might be things like how to handle when someone logs off, right? Just how do I handle that? How to handle stormy conditions, right? There's a storm. Oh man, like the lines are down. A tree fell over the line, right? Just in the middle of the thing. How do I handle that, right? That might be something that I want to write in here. How to handle multiple people using the tin can phone, right? That might be yet another question that I want to dive into. Is maybe these are two tree houses that don't just have one person in either one of them, right? Maybe both of these tree houses have like 6 people in them, and they each take turns using the phone. And so I might want to come up with protocols for that. I want us to see that that is yet another layer that's a little bit different than just having a conversation, right? Because I might say that maybe handling sessions, if I had this one tin can phone, and I have 4 people on the other side and 4 people here, each of whom is talking to each other, so there's 4 conversations. And how do I handle that? Right? How do I make that possible for 8 people to be talking to each other in pairs? What's that? You could have a code for each one of them, right? So maybe here are some options. We'll do options for this one. So options is like each conversation has a code, you mean? Right, so each person has a code, right? So that way, if I'm talking to someone, a user or an agent may give their code right when they hop on. And they hop on. This is Sergeant, whatever speaking. I forgot to come up with the names. I may give my code, and then there's no ambiguity about who I am, as long as the person was listening to me ahead of time. But there's a chance that I hop on. I say, yeah, this is Sergeant. I still didn't come up with Sergeant Whiteboard here. Did you ever watch? There's like that Family Guy episode where Peter Griffin has to like come up with a fake name. It's like P tier, and then a griffin flies across. Griffin, P tier Griffin. This is Sergeant Peter Griffin. I'd like to hear the status of the pizzas, or the pizzas arriving anytime soon. And maybe while I'm talking, the other person just gets offline and another person comes on. Right? And now that person doesn't know who they're talking to. Right? So if I just continue talking, well, yeah, I would like bananas and pineapple on top or whatever, the other person may go like, what are we even talking about? Who am I even talking to here? Who do you think you are making these decisions about this pizza? Right? So what I might want to do is maybe instead of giving my code every time I hop on, an agent may give their code, right, at the beginning of every message, right? This is sort of like when my dad texts me, he always signs his texts, right? Nima, how are you doing? Dad. Like, Dad, I see it. And you know what? He knows. He's like an engineer. He's a database architect. The dude, I mean, he's got plenty of experience in tech. He knows. But he does it because it's fancy, I think is the thing. Like, sincerely, father, right? But there's no ambiguity. I could be in the middle of the text. I'm like, who's this texting me? Right, it's my dad, because it's down there. Right? So I might do that on the tin can phone. Right? You're talking to Sergeant Whiteboard again, right? Every time. Obviously, now we're incurring some overhead, right? And when I say overhead, I mean there's some cost to each message. Right? If my name is really long, for example, I need to say that whole long name. And people might get angry at me. Like, why couldn't you pick a shorter name? Right? Or maybe we come up with code names for our code names, right? At the end of the day, though, we have to attach now this thing at the beginning of every message, right? So our message isn't just the content that we want to transmit. It's a bunch of extra stuff that identifies us, maybe identifies the conversation that we're having, right? This thing here handles multiple people, but it doesn't actually handle multiple conversations happening at a time, right? Because what I'm saying is that I want to, maybe agent A wants to be on the phone with agent B, right? Agent C wants to be on the phone with agent D, and E wants to be on the phone with agent F, right? But there's only one phone. And these are 3 separate conversations. Okay. How do we come up with a rule that fairly lets everybody have, like the chance to have their conversation? Yeah. Sure, maybe a first come, first served queue. So if A and B arrive, they start talking, and C and D are just waiting. They're like, man, we had our treehouse call scheduled for 4:30. I'm way behind schedule right now. The banana and pineapple pizza is going to arrive anytime. Sergeant Whiteboard is going to be furious. No, but they have to just wait until the conversation's over, right? That doesn't feel super fair to me, right? But it works, sure. So we could just wait, deal with it. A very American way of solving that problem. Like, I got mine. Time division, absolutely. Okay, time division, meaning. Do you want to explain what time division is going to mean?
Yeah, sure. Well, A and B talk for 1 second, C and D then talk for 1 second, and E and F talk for 1 second. And then on the queue, it goes back up to A and B, and it talks for another 1 second, 1 second, 1 second, and then goes up, and then.
There we go. Yeah. Right. So 1 second, 1 second, 1 second. So these people here might be registered for all of the 0. So this would be 0, 3, 6, and 9. Did I get that right? Yeah. This would be 1, 4, and 7. I didn't get this right. Oh no, I did, because you can't really. You kind of get what I mean. Like it like cycles that way. Yeah. Sure, absolutely. This is pretty fair. Do the conversations suffer for it? Yeah, they do. Right. Now we have to have like some extra thought going into, both of these agents need to like keep track of both their time, like how much time they're spending, right, and all of that. Right? But at least we're getting to a place where this could be solved. Right? Maybe instead of talking for 1 second, we could say, a minute, right? A second is a little draconian, I'll say. Like that's 1 second. So we might do 1 minute. And absolutely. Right. So there's different things that we could come up with to solve this. And again, I want you to see that this here is a layer on top of the actual conversation. Right? It's a layer on top of the actual conversation. What I mean is that during the conversation, A and B, right, while they're talking, they're not even thinking about the fact that they only have 1 minute, right? Or like that's a thing that happens. At the end of the minute, they just get disconnected, and then they get reconnected, and maybe that's something they have to account for. But it doesn't change this part too much, right? They're not necessarily distinct, but they're starting to get separated a little bit. And if we really put some work into this, we could probably find some way to like completely decouple these two things. Yeah. So here we have like a fully fleshed out, well-realized kind of system, right, for handling sessions. This is still sort of set so that it's a maximum of 3 people on either side, right? But I might come up with rules on top of this to make this like dynamic, right? Some like dynamic time division and stuff like that. So what we've invented here is essentially the internet stack, right? For our like intents and purposes today, pretty much all of it except for like extra things, which we'll talk about at the end of lecture. Right? Ooh, always leave them wanting more. All right. So we'll talk about the extra bits a little bit. I'm going to just kind of show you something very briefly, and then give you a break and let you chew on this a little bit. You know, maybe think about how you might design a system like this if you were to start from scratch again. And what we're looking for is the, oh man, why am I? Oh man, I'm like hardcore like crashed. The protocol stack. I'm looking for. I'm looking for a particular word. There we go. OSI model. So what we've invented is something that sort of loosely follows what's called the OSI model for networking. OSI stands for Open Systems Interconnection Model, right? Open Systems Interconnection Model. This here is about computers. Our thing was about tin cans and people. We're going to find a lot of very kind of close relationships. The OSI model is structured into layers. And, we haven't worked with all of these layers as we're building up the tin can, and our layers are slightly different, but there's still that layered kind of process to it. They start off with the physical layer. Right? The physical layer says, you know, what is it physically? Okay, well, these wires and stuff like that. Right? Data link. How do the wires like carry information between like one wire to like a node, and then that, like those, the actual links between them. And when we get higher up, when we think about the actual network, you know, we're not looking at just a wire to a particular node transmitting information here, but rather a network of wires and nodes, right? A bit more abstracted, and looking at the rules that we have to come up with to facilitate communication there. Transport layer is going to mean actually having a message go from point A to point B in the network and ensuring that it arrives there. Right? That's getting to our idea of, you know, if we send a message, right, for acknowledgement, and then we wait to see if that person's received it, like received the acknowledgement. I'll phrase that wrong. Send a message saying that I want to talk, wait for acknowledgement, and then send a message to ensure that like your communication is actually reaching the endpoint. That's getting into that idea of transportation. Right? Session is getting a bit closer to what we just did right now, which is ensuring that like different people can talk at the same time, but also that the context of a conversation endures and it persists. Right? And then there's these other two layers that we'll likely not explore in lecture, but I recommend kind of reading about. I don't think in the curriculum we even say OSI model. Right? I don't want you to go online and like, oh, really, like I need to learn the OSI model. Right? What I want you to just start thinking about lightly is that there is a distinction, right, between the medium for communication, right, how it's used at like a basic level, how it's used to have like richer conversations, and then even further, when we want to have conversations about particular things, we might come up with shorthand for that stuff. Right? So for example, I'm very loosely saying if like under extra bits, if I wanted to have pizza conversations, right, I might want to come up with a really short, concise format for what a pizza order looks like. Right? For example, when I establish that I'm having a conversation, I might just say pizza order, bananas, pickles, pineapples, anchovies. Right? It's good old treehouse food. Right? So it might just straight up be pizza order followed by ingredients or toppings, and then over. Right? That might be a format for a pizza order, and it's just concise. Right? And every other conversation is a little bit less dense in terms of information. Right? But the pizza order is like we've really nailed that down. See, again, this is a rule on top of how we communicate to make that communication a bit more kind of facilitated. You see what I mean when I said I wouldn't be like writing any code in the first half of the lecture? We still got through a heck of a ton of stuff. Which part? This, the pizza order toppings over. I'm going to say that that's more of a sort of in here. transport layer. We'll explore this a little bit in the second half. I'm going to make a where on the layer does this live. We'll say this is like HTTP. So when we talk about HTTP, this part here will make a lot of sense. Are we good to take a break? Yeah, unless someone wants to like stay to like round it out to 11. I really want that like nice round 11. Nah, treat yourself. Meet up at 11:11, and we'll start the lecture with a wish. Yeah, we'll see each other in a couple minutes. All right, everyone. All right. So I guess bad news, we didn't get to make a wish as a group, but I hope you got a chance to make a wish. That's important. You got to take every opportunity you get to cash in on that stuff. Oh, man. Yo, what's up, dudes? Yeah, all right, that's all good. No, it's the three of you. Don't worry. Sorry, lecture will be over like soon. It won't. There's still quite a while. Welcome back. We're not gonna go back to like fleshing out the tin can phone. Like, don't worry, we're done with that. In terms of theory, we will now build the tin can phone physically. No, that would be fun though. Like an entire. If I had full control over the curriculum, there's KV. Oh, he's got his earphones in. If I had full control over the curriculum, first 2 weeks would all be hands-on exercises, building things, playing board games, computational thinking exercises. There'd be like hardly any programming. People would hate it, but I'd have a lot of fun. I guess this is something I didn't talk about when I introduced myself last week. I've been teaching for like a couple years. Originally, I taught kids, like kids programming, and I did that for like quite a while, even when I started teaching here. So I don't think I do it as much now, but like definitely like a year ago, when I would teach here, I would like sometimes talk to people as if they were children. But then conversely, like I talk to children as if they're adults, so it just kind of like blends in together. But one of the things that I used to teach a lot was I'd teach teachers how to teach kids programming. So last year I got to like go around and teach like professional development conferences around the country, showing like high school and elementary school teachers, like French teachers, social studies teachers, science teachers, all the things that like they could do to integrate computational thinking and coding and like information tech and whatever into their like classes, because in a lot of provinces and these territories around Canada, like that's become part of the curriculum. If you're a social studies teacher, you got to try and figure out some way to put in like computational thinking into your thing. You're like, how do I do that? I don't know how to code, and it's not always about coding. And one of the big things that we did was what we called unplugged activities. And so let me just look up. The thing that I worked for was called, they're called Canada Learning Code, and I taught for teachers learning code a whole ton. And one of my favorite activities was do the robot. And do the robot is, they took away, there was like a cute picture. What do the robot is an unplugged challenge to get students thinking about simple instructions, sequences, and creating algorithms. So in this activity, and this is something that you might want to do as like a thought experiment while you're on the bus, and it's very similar to what we kind of did today, is putting yourself in the space of like both the programmer and the robot, and thinking about how explicit you need to be to give instructions. Right? So in this activity, every kid like pairs up, and one takes the robot role, and the other one's the programmer. And they'll be like, oh, okay, well, the programmer wants to program the robot to sit in a chair. And the robot will be as like stubborn as possible and interpret things as like literally as possible. And it gets people thinking like computationally. Right? The reason I bring this up isn't just like, oh, you should play games. But I really encourage you to like step away from the computer sometimes and try to think computationally, right? Like put yourself in like a place of empathy, right? From the point of view of the machine. And from the point of view of the people who programmed this stuff originally, and try to like really see where this stuff is coming from. I think that becoming a programmer is like a holistic thing, right? It's not just about doing a lot of exercises, but it's about like kind of really seeing the problem space. We'll come back to this over the course of boot camp. Whenever I lecture, I like talking about this stuff a little bit. But I want you to keep that in mind as we get into the second half, where we're actually going to start writing some code, right? And we're actually going to write code that doesn't work at first. Right? what we're going to do is I'm going to extend this kind of thought experiment process, so not about the tin can phone, but more about writing code and imagining what that code's going to look like. Right? So like sight reading some code that doesn't actually exist. That process is going to feel really weird, right? But I think it's pretty valuable. What we're going to do is I'm going to make myself a folder, old2. Put that in there. What we're going to do, no, I shouldn't have done that. I moved all the wrong stuff. I moved literally all the wrong things. That was file MD, goes out here. These three go into old. And then client and server go into old too. There we go. Whew. Clean up. So what we're going to do is we're going to talk about a thing called TCP. Now TCP stands for the, why do I always forget? The something control protocol. What, transmission? Transfer? Maybe. TCP. Transmission control protocol. Ouch. Ouch. Transmission control protocol. Right. TCP stands for Transmission Control Protocol. It's not a protocol that you're going to be working directly with very often, right? But it is a part of the stack, as in it builds up the entirety of the thing that you're going to be working with. Right? It's a part of that system. Like, again, to put words to it, you'll be working with HTTP most of the time, right? But HTTP is going to come up later. I think tomorrow. Yeah, tomorrow, I think. We're going to focus on transmission control protocol. I'm going to first kind of give an analogy. Right? The analogy here is that if we were to have a highway with cars and trucks and other vehicles going to places, right? This is a thing, right? There's a highway, maybe an interconnection of like highways, and anything can go on there. Trucks, maybe you've got yourself the truckla, or what they call it, the Cybertruck. And you got yourself a little moped, right? You're just going from point A to point B, and usually you're carrying something. I mean, there's this big general purpose thing. Examples of things that can go on the highway, like I said, cars, trucks, mopeds. And then each of these things may be carrying something. Right? So a car may be carrying some people. Right? Maybe this truck is automated. You know, maybe Elon Musk won and automated trucks. But this might be carrying some cargo. Common cargo to carry: pillows, I don't know, boxes of packing peanuts. By volume, that's probably the thing that gets transported the most, right? That's a horrible joke. So trucks are going to be carrying stuff, and specifically I'll say that there's cargo in here. And there's three things. There's the highway, there's the vehicles, and then there's the cargo. Right? The highway is going to be the internet protocol, right? Or IP. And I'm not going to dive into that too much. I'm just going to say, oh, there is a protocol called internet protocol, and that behaves like a highway. Right? It's not even strictly true, but it's good enough for our analogy right now. The trucks themselves are going to be TCP. Right? So they're the things actually transferring from point A to point B. And then there's HTTP. I got this backwards. Probably did. What? No, I got this right. Nice stuff. Good me. The trucks themselves are going to be TCP, right? Stuff going from point A to point B. And then HTTP is going to be the actual cargo. on the truck. This might not help a ton right now, right? But I want you to try to take this analogy and kind of like draw yourself back to the tin can phone on the treehouse. Right? How there's a difference between the actual phone system, right? There's a difference between that and the messages that get sent between the phone system. And then there's the difference between that and the messages about pizza. Right? Those are like the particular cargo. Right? The messages about pizza, that's like really kind of salient data. So TCP is this thing here that lives in the middle. It basically facilitates the transmission and receival of messages. Messages. Super vague. Just messages. Data. Right? All you know with TCP, if you send it, it should be received. Right? It should be received. TCP as a protocol, right? And we're not going to look at exactly how it's built at all. But TCP says if you send a message, it should be received. How does that work? You don't know. You don't care. You just know that if we have a TCP connection, right, we essentially have this wire between two people. If I send a message, that will be received. And we can assume that underneath, the way that TCP is built is just like our tin can phone with rules about how messages are sent and all that. Right? But for us as users, we just get to look at it as two wires. And if I want to send something, I send. And I can also receive. And TCP is going to allow me to listen and send like at the same time. Or it's going to feel like it's happening at the same time. So with TCP, I'm going to lay out a couple words. There is going to be this idea of a connection. And the connection happens between two agents, A and B. These two agents have different roles in a TCP communication. One of these agents is going to have to be the host. Right? And the other one's going to have to be the guest. What that means is one of these people needs to be the first one to kind of start that thing. They need to be housing the communication. And then this other person can send messages to that person. And then this person may send messages back. TCP is what we call a full duplex, right? Meaning you can send messages and you can receive messages at the same time. So there's a guest and a host, right? And the words that usually get used instead of guest and host are client and server. Right? You're going to see the words client and server a lot. To put this into just kind of as boiled down as it could possibly be, I think, like not even talking about technically, like implementation and all that, a server is someone that clients can connect to. How many clients can connect to a server? It depends on the server, presumably many, right? Maybe infinite, who knows? Depends on the server. Right? But many clients can connect to the server, and the server can then talk to other clients. Can clients connect to other clients? No, not in this model here. Right? In this model here, clients are people that connect to. If a client could connect to another client, heads up, you got a server. That's not a client, right? In our situation. Yeah, if we were talking about peer-to-peer, that would be clients that can talk to each other without a server in the middle, right? Here, we're going to be talking about two agents, right? A to B, where one of them has to be a server. If I had like three people, A, B, and C, then A wanted to send a message to B, we might have to set up the server to be able to relay messages, right? So A sends a message to B saying, hey, can you send this to C? And then B is going to send it to C. And we'll code that up. That's what we're going to build over the course of the next little while, right? Is this situation where we have one program running that is waiting for connections, another program that when it runs tries to make a connection, and then once they're both connected, they can send messages to each other. Does that conceptually make sense? So let's start thinking about how that would be coded up. We can start on either side of this, client or server. Right? These are going to be two separate programs, right? Because they're going to be two separate people. So if I wanted to start off and make myself either the client or the server, which one do you think you want to do first? If you want to do server, that's cool, right? We could totally do server first. I'll tell you, it doesn't actually matter. So yeah, let's say we wanted to make server. Make myself server.js, right? And we could start off by like trying to write some code in here to make my server.js run. So if I was to break down what I want this server to do, so I'll just write this out and then comment it out. When this script runs, oh wow, oh man, runs, start a server, right? The server should listen for connections, right? And then let's just say when you get a connection, console.log new connection. We're going to add more to this, right? We'll like when we get a connection, we'll want to probably send a message back and all that. So this is our start. How do I do this in JavaScript? Like what do you think I'm going to need? And when you really think about how, if you were to build this from scratch, and imagine there were all kinds of helper functions for you already, like whatever you come up with as correct code, how are you going to write this? Create a new connection. So is this server supposed to create a connection?
No.
It's supposed to. Is it supposed to open up a connection? It's supposed to receive a connection and like listen, right? Right. So there should be someone who can listen. The server should listen for connections. Right. So I need a server, evidently. Like I'll need some server. Where does this server come from? Huh? I mean, yeah. I'm thinking less in terms of like real code and more in structure. Right? This variable server, it needs to come from somewhere, right? Where does it come from? From a specific module or something, right? So I might require server utils, require server utils, right? Maybe that's what we're going to do. Now we have this server utils module that maybe has all kinds of helpful like helper functions built inside of it. And now I want to make a server. What do you assume I'm going to have to write? Server.listen, sure. Right, so maybe server.listen, that might be a function call. Right? I still don't know where server is coming from. Is server in scope here? So server utils. Right? So are you saying I should go server utils.listen? Right? That could make sense, right? Maybe server utils immediately gives me a fresh server that I can start listening through, right? Like maybe it gives me a fresh server. Often that's not going to be the case, right? Often like a utility library isn't going to give you like a ready to go thing. We'll have to use a helper function to create something. So there might be a server utils dot something else, right? Let's guess. What could we put in there? Start. So server utils is going to be a module for us in this thought experiment. It's a module that holds a bunch of helper functions, one of which might be used for like creating a server. Right? If I'm seeing this thing here that says server.listen, this needs to come from somewhere. So somewhere I'm going to have to go const server equals something else. Right? What could this on the right-hand side? What could that look like? IP? Right, so maybe like 192.168. Whatever, right? Sure, but this is a string, right? Not a server. Yep. There we go. Can you say that a bit louder? maybe it has a function, right? So I might go server utils create server, right? That's going to be the idea here is I'll bring in a library, right? And then that library will usually have something that I can use to like create a server and put it into a variable. And then that's going to allow me to attach a bunch of things to the server and tell the server to do stuff, such as server.listen. And server.listen. So I'm not doing this to torture you, but to really get you to start thinking about, like, you can design your own stuff like this, right? Generally start with, like, what's the endpoint going to look like? OK, well, I'll have a server. Where is this thing going to come from? And that's how you process and you come up with what your structure for your code is going to look like. You're also going to see that when you learn server stuff today, right, the stuff that you learn and play and work with today, that's not the stuff that you're actually going to be working with tomorrow. Right? And it's not going to be the stuff that you're going to be working with next week. You're going to be playing around with like a lot of different servers over the course of the program. Right? And I really want you to take a look at how they're very similar in structure for when you create them. Right? And they all come out of this process. Right? I'll need to bring in something, and I'll need to create a server. Now that I have my server and I'm listening for connections, how do I write this? When you get a connection, console log new connection. Right? Where should that go, do you think? Right? So I might say server listen on a particular port, right? Sure, 8080 or something. Do you all know what ports are? Is anyone here not sure what a port is? Cool. All right, so we're going to put the word port up here because I have that planned for something we talk about in a minute. So port. So let's say that it's just listening. Right? How do I say that when you get a connection, console log new connection? On connection, what was that? Maybe an event listener. Do you want to explain what an event listener might look like in this scenario? Because you're 100% on the right track, and same with the on connection, right? But like, where is that going to be? I don't know if I can just write on connection like this, right? Because this needs to be attached to something. Sure. Maybe something like this. Yeah, server listen dot on connection. That could be a thing, right? Could make sense. I might find this confusing myself. I might like this more. Server dot on connection, right? And then this is where we could argue and come up with something. But at least we're getting somewhere. When somebody connects to the server, right? Then I want to console log new connection. How do I get that to happen here? Use a callback. Now, why do we have to use a callback? There you go. Does that make sense to everyone? Right? We don't know when the connection is going to happen. I can't just go just over here console.log new connection, because this is going to run immediately. It's going to immediately just console log new connection. I need to attach this to say maybe when there is a new connection, then run this function, right? Console log new connection. I want to highlight, this is not real code at the moment. We're like inventing our own server library here. Right? We're just building it from scratch. But we're going to see that real server code is going to look pretty much identical to this. Right? I think a lot of people, when they see server code for the first time, get really confused about why are there so many callbacks? Why is this stuff all over the place? It really comes down to the idea that you don't know when these things are going to happen. So I'm going to attach that thing, the console log new connection, to a callback, and I will trust that when there's a new connection, the server will call on connection. That's not in my control. That's in the control of the people who made server utils. Okay? That's not on me. Right? If I was the person who made server utils, then in there now I would have to write some complicated code to actually call on connection anytime there's a connection. Right? But that's been abstracted away from me. Right? When you're coding like server work, you're often just a puppet master on the outside dealing with some pretty complicated thing that's already been built, right? And you're leveraging that. So when there's a new connection, then I might console log new connection. If this doesn't make a ton of sense right now, that's fine. We're going to look at this again in real code. And, now I'm going to do the client.js, right? The client.js file. This is the client side of things, right? Meaning when this script starts, right, create a connection. Right? That connection should be to the server's address, right? Often an IP address, right? So my server is running somewhere. My client is usually running somewhere else, right? So they need to, the client needs to know where the server is. That connection should be to the server's address, and maybe that's OK for me right now. As a stretch, I might say, after connecting, send a message. So what this is likely going to look like is I might bring in const client utils equals, and then maybe I have another library that is client-utils. And very similarly to the process that we just went through now, I would ask myself where this comes from. I might go const client equals client utils dot maybe create client, because it has to come from somewhere. And client utils dot create client. I might pass in the address, so 192 point blah, 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 whatever, right? Some address. And now, depending on the library, maybe this creates the client and opens up the connection, or maybe it's just preparing it but it hasn't opened it yet. I might have to write some code that's like client open connection or something like that. And if I want to send a message, I'll want to make sure that that happens after we actually open. So I might do something like client.onOpen. Maybe that's a thing. Or it might make sense if the people who made the library made it so that you can pass a callback directly into open, right? So after I've opened, now I want to send a message through here. Right? We're going to take this and we're actually going to turn over to look at real server code and build this up real, and it's going to be virtually identical, right? Pretty much identical. And what we're going to have in just a couple minutes is a system that from a client sends a message and the server sends a message back to the client. Right? I want to say, do not necessarily pay too much attention to the code itself. Pay more attention to the flow. Right? So syntax-wise, if there's things that are confusing, that's fine. You're not going to be using the library that I'm showing you today for longer than just today and tomorrow. Right? The library that we're using today is for educational purposes. It's very, very low level. Right? You're going to be using other stuff in the future. On Monday, you're going to be using other stuff. So we're going to call this one brainstorm. That's where I'm going to put our client and our server. I'm going to make a folder called real. Right? Real HTTP. Things are about to get, not real HTTP. That was wrong. Real TCP. And I'll make two files, just like we did a second ago, client.js, right? And another file called server.js. Right? Except in both of these, instead of bringing in my fake client utils, right? There's actually a library that I'm able to bring in called net. Right? I'm going to check to see if I got this right. Console.log net. And I'm actually going to do the client side first. So let me just see if I got this right. Node, so cd real TCP. Cool. So what I did right now is I console logged this net object. If we take a look through the net object, we're going to find things like create server and create connection. These are functions that exist. Right? The people who made the net library decided to leave that in there. The net library is built into Node, so you don't need to npm install anything. It's just there. there are other libraries that will like make it fancier. So you're gonna find with the net library, we have to do a lot of legwork. I might want to use that create connection function. So I could go const connection, right? Or maybe const client equals net.create connection. And I could take a look at what the documentation says. I could go online and find out that create connection is going to take create connection. I just have an example of it here already. Is going to take a host that it's going to point to, and it's also going to take a port. And that's that word they used there a second ago. Let me just do that. So it's going to take a host, and that host is going to be my address. So localhost in my case. Okay, but I could put my IP address in there, and in fact, that's maybe what I'll do right now. I'm going to go and 88211. Exactly. This is going to be the IP address of the server, or just the general address of the server, right? And then there's going to be a port, because a machine can have many network connections, right? I can have many programs that are running and they're all connected to the internet. It doesn't make sense for my machine to only have a single program connected to the internet at a time. Right? You're like, oh, I want to use Slack, but I have Chrome open. Oh no, and you have to like close Chrome or whatever. That would be annoying. Right? So instead, our programs are going to be able to register themselves on a specific part of the machine. These virtual like ports, they're like windows that programs say, I own this and this is where I am. And they're just numbers from like how many ports are there in like TCP. If 65,000 choices from 1 to 65,535. Just pick a number. I think the ones that we've already picked for you on Vagrant are like 3,000, 80, 80, and some other ones. But ideally, like you could pick any ones you want. So here I might go port, and then on my machine, I don't know, my favorite number is 1337 leet, and then this is the client. This is where I'm supposedly creating this thing. This means that when I have my server, it should be on port 1337. We'll see that in a sec. I'm gonna run my client right now. Because I wasn't running in the right file, my bad. Well, I'm gonna run my client right now. I get an error. Connection refused at this particular address. Why was it refused? There's no server, right? So I've got to make a server. I'm going to go ahead and do the same thing over on the server side, except instead of it being const client, it'll be const server equals net.create server. Right? And to the net.create server, if I took a look through here, among the things that I can pass, and I'm just going to have to look up my notes real quick. Among the things that I can pass, is nothing. I don't pass anything to it. But we'll see right now if I run node server.js, it's fine. Is it doing anything? No, it just opens and dies. You like breathe life into this universe and then you just take it away. Right? Nima giveth and Nima taketh. I need to tell my server to listen somewhere. So after that's because I was never calling this function in the first place. But still, it's still going through. To go server.listen just like we did before, and this is where I say the port. So I might say server listen 1337. And I go ahead and I go node server.js. Something's happening. Something is happening. Now hold on to like the edge of your seats, because things are about to get genuinely whack. Like I'm about to take you on a 10-minute adventure. I held off on writing code. I'm going to write a bunch of code now, right? I know that it's frustrating if you see a bunch of code pop up. Trust me, that's the point. You're going to be working through every single one of the steps that I'm going through now over the course of your assignment. Right? So let's say my server is not running, and I run my client. So node client, it dies. If my server is running, and I go to my client, there's been a connection. Right? They're just waiting. This is sort of like those phone calls where you're on the phone with someone and neither of you has anything to say, and you're just like, and you're like aware of how loudly you breathe. That's what this is. And now we have to think of something to say. Right? Now we have to think of something to say. I can make maybe my my server here, right, say something like when there is a connection, console log something. Server.on. There is an on connection. Their syntax is slightly different to the syntax we came up with. It doesn't mean it's the best syntax, right? But they just picked one. They have a bunch of event listeners, so they decided they're going to go server.on, and then you pass it the listener that you're waiting for. So anytime there's a connection, it's going to run this callback. And I'm going to go ahead and go console.log new connection. Anytime there's a connection. I can go ahead and run my server. This is my server at the moment. Go to my client. I'm going to keep running my client and stopping it. And what you're going to find over on this side is new connection. Heckin' what? What? Now you can do anything. Right? You want to see what's just genuinely nuts is if I was to give you this code here, right? Yeah, just this code here, and if you were to run it in Slack, not in Slack, sorry, in on your machine, you're going to be calling my server. So for whoever's interested, like a couple of you want to try it out, take out your laptop. So I'm going to be writing some code and pasting it into Slack, and I'd like a couple people to try it out because I want you to see that like multiple guests are connecting to the one host. So feel free to go get your laptop for a sec. I'm going to start writing some more stuff here in a second. So I have this client, right? I have this client. I have a server, and this client is making, like sending like a connection. I want to send some data from the client. When am I allowed to send data from the client to the server? After the connection. So I can say, oh, the client after you connect. So client.onConnect. That is when I'm going to send some stuff. What do you think I'm going to want to write in here to say I want to send a message to the person I'm connected to? Yeah, so maybe a console log. Now console log is going to be local. If I want to send a message through the wire, I get to use write, right? I get to use the word write. Now, I just want to ensure that I'm doing this properly. Yeah. I'm going to be able to go client.write hello world. And client.write hello world means that when my client is running, that message actually got sent. Do I see it on the server? No. Right? The server has received the message, but have I told it to do anything with that message? No. So now I get to say, okay, when the server receives the connection, when it receives a message from that connection, then it should do something. Right? This one's kind of weird, and this is definitely a place where I want you to like really pay attention to this. How am I going to say when I get a message from someone? What do you think that's going to look like? That could be one way to do it. And I'm assuming you mean up here, right? So the way that I want you to read this is when someone connects, right? Then what you get here is that actual client, right? Or that actual connection. when someone connects, here I have access to that person, right? Con. This is what's going to give me the ability to actually hold on to a particular connection. When somebody connects, then I can do all kinds of stuff with that connection in here, including I could say when that connection sends me some data, right? When that connection sends me some data, then maybe I want to console.log new data. Right? And what I'm going to see now is if I start my server again, and if I start my client again, over on the server side, I'm going to see both new connection and new data because my client is sending some data. If I wanted access to that data, a hot dog, I got access to it here, right? Console log, new data. Let's see that data. Show it to me. What do you think we're going to see? If my client sends me hello world and my server console logs that data, what am I going to see? I might see hello world. Well, hold on to your seats because we see a good old new data buffer 4865.6c, right? But it's something. It's some data. When data goes down the wire, it's just zeros and ones. This thing here is essentially saying an array of zeros and ones. Now, those zeros and ones may be, they may be images. They may be text. They may be audio files, right? They may be all kinds of stuff. Right? It's up to me to say how I should interpret that. Right? So it's up to me on the client side to say, this is the kind of data that I want to send and receive. And then it's also up to me on the server side to say, oh, I'm going to interpret the data that's coming in as something. And I'm going to say that this is going to be text. So I'm going to bring in some text, some code. I don't want you to like freak out over it. This is going to have to happen on basically two ends here. Some code. The first place where I'm going to do this is I'm going to do this over on the server. I'm going to say that when somebody connects to me, I'm going to set their encoding to UTF-8. You do not have to do this with other tools. It's just that the net library is garbage. Like it makes you do a lot of work. Usually we mean to send data, so like we don't have to write this. But with the net library, I do. So I'm going to go ahead and send this now. And my server is going to interpret the stuff that comes in as UTF-8, meaning text. Right? UTF-8 is just another, it's a standard for text.
Is there a way, like, because the server already knows what kind of data it's get? But, so then if the client sends, music type, is there a way to send with that the type of data?
That's a really good question. So in this scenario here, notice I haven't written anything new on the client. Right? UTF-8 at the moment is only written over on the server, and it says interpret what the client sends as UTF-8. My server could set this to anything, right? If I wanted to be able to like switch types of data, then I'm going to need to come up myself with a protocol for the client to tell the server what data I'm sending. That's a really good question that actually leans into HTTP that you're going to be learning about tomorrow. Right? I'll be pasting it in the thing in a second. So this here is the client at the moment. I want to try in the next like 3 or 4 minutes to turn this into not just sending client.write hello world, but instead sending text that users write. Right? So yesterday you worked with the standard in stuff, right? So I'm going to paste in some code. I'm just going to trust you to kind of deal with it. Right? So here is something. Among the code that I'm pasting in is standard in. So we're going to see that right here. What this says is bring in process.standardin. I just like having stdin instead of process.standardin all the time. We're going to say standardin.resume. What this means is standardin is going to wait until I press enter. right? And then when I press enter, then it's going to take the input, as opposed to taking every key. It'll take in lines at a time. Right? And then I'll tell standard in, you've seen this yesterday, I think, interpret the text that's coming in as text, as opposed to just binary stuff. And then on top of that, what I'm going to do is I'm going to say, up here, just like you did yesterday, whenever somebody enters some data into standard in, so you saw this line before, right? Am I wrong about that? Huh? So you saw this line yesterday. Whenever somebody writes in some data, I'm going to run a callback. And what I'm doing is I'm checking to see if that data is the \q is to quit. Right? So I have a \q that just exits my process and closes my client. I guess I wrote that down here. But then the other one is that when you write something, it goes client.write with that data. Right? And now over here, I think that's really just about it for the moment. If I go ahead and I stop my server and turn that on, and stop my client and turn it on, I can write things, and over on my server, it's actually going to receive that. So if I was to give you my client code at the moment, if you were to run this, then you would have something where you can write, and you're actually going to see messages pop up. Ayo, it's your boy. That's not me. That's you. Is that you? Yeah, it's awesome. Right? You're in. Like you've hacked into the system. That's what we're setting up right now. Is today you're going to be all working with that TV. Right? Now, this is messages coming to the server. Let's set up messages going from the server to the client. It's going to be almost identical. Right? Over on the server, I could say, hey, whenever there's some data, I might go connection.write, and then I might write that data right back at them. Right? Data comes in, and then data just gets written back to the original user. And now I'm going to find that node server. I'm not going to see this immediately, but on my client, what's happening is the message is actually being sent back. So I need to write some code to actually show messages when they arrive. And so here I'm going to go on the client and say, oh, OK, well, whenever there is data, console.log the data. And any data that my client receives right now, it's going to just print. And I start my client. Whoops. I forgot to write data in here. Data console log that data. Now, whenever I send a message, what I get back is buffer. How do I handle this? UTF-8. So I get to say that my client, and I might do this up here, it doesn't really matter where I do it, but I like to keep all my config stuff at the top. I might go client.setEncoding to UTF-8 so that it understands the server as well. Now those messages come back. And now we have a chat bot, essentially. Or not a chat bot, sorry, a chat app. Right? You send a message and you receive messages. Except I only receive messages from myself. I don't know if someone's sending messages right now, you don't see them pop up on my screen. Here's the last thing we're going to do. Right? The very last thing. If I wanted my server to send messages not only to the connection, not only to the person who sent the message, but to everyone, what am I going to have to do? So there's only one port, but there's many connections, right? Here I'm saying, like anytime there's a new connection, I do stuff with them, right? If I wanted to send a message to lots of people, right? I think I've said this on Monday. When you want to go through a bunch of stuff and do something to each one of them, what do you use? A loop. What do I loop over? Do I have something I can loop over right now? Huh? I might want to loop over the connections, but I don't have a variable that holds my connections. So the last thing that I might do is I might go const connections equals an empty array. Right? And then anytime there's a connection, I might go connections dot push that one connection.
And what is it going to put their IP?
I don't know. It's going to put in there the connection object, and I recommend you console log that to see what it is. It's going to be a big object with some stuff that you can do inside of it, but it's going to push objects, right? Because at the end of the day, each of these things is just a JavaScript object. Right? And then what that means here is I don't just write back to the user. I can go for const user of connections. Every user in the connections, I can write that message back to everyone. User.writeData. And this here might feel like a huge step. You're going to do this again in the future. I just wanted to put it on your map, and then you're going to be working with this stuff. Again, every single step I went through today, right, each one of those is in the assignments. And now, just to kind of show it as it works, if someone wants to connect to this right now, then we can verify that it works. So I'm going to stop and start my server, and then just feel free to start your client, and we should start seeing messages pop up. There we go.
That's the client code you posted?
Yeah, I posted the client code. Anarcho-primitivism makes a lot of sense. Did you see the memes? The anarcho-primitivist memes are super weird. Hello world. There we go. Someone's connected. And now if you were to type something and press enter, you know, hey, what up?
Are these both these pieces of code, like you posted it, pasted it twice?
I've pasted it that it's newer. So you can replace the code that you have with the newest thing. And there we go. And we have a chat app. What I want you to take from this today is networking as a concept has to come from a place of like empathy and thinking about like how, like why are these things connecting? There's layers to it, but ultimately also that TCP has a host and a client, right? Or a server and a client. And you're going to get a lot of work with this. Cool. I think that's about it.
Could you go to your server side just real quick?
Yep.
So when you have a connection,
Mhm.
that's basically when you're connecting. So what happens when you disconnect?
That's a great question. What happens when you disconnect? I don't know. Am I handling that right now?
No.
So I might have to write some code for disconnect. I could check, is there such thing as a connection dot on end? There is a connection on end, so I might want to do something when somebody disconnects. Right.
Connection and end are predefined strings that are built within that library.
Yeah, this connection, this data, and those are predefined like strings that are built in. So I would look at the docs to figure that out. VS Code will also just like show you what the options are, which is kind of nice. That's a great question. Cool. Are there other questions? Dope. Yeah.
Real quick, I got a message saying econ refused.
Oh, that's because I stopped my server. But if I started it up again, then you'd be fine. Yeah. Now we got. I love that first message. Great. Just. Yes. Technology. That wasn't me. Cool. I see. It's like I believe that it wasn't you, but also I'm like, yeah, okay, it wasn't you. Cool. Allie. And then if you /Q, it should quit. Have a great rest of the day. I'm gonna send you the notes, but they're also just immediately in the lectures. If you scroll down, you'll see them. They're exactly the same. Like I did the same lecture. Let me know if you have questions during the day. I'm mentoring. Cool. All right, thanks everyone.